Hey guys, so today, Algebra 2, Section 7.2 notes. And, whoa, man, quick story. So, typically, I put in more effort into your guys' notes than I do Algebra 3's because, well, to be honest, I did all yours in the summer. And, well, all your setups in the summer. And I have more time in the summer, duh. But I totally forgot that I had already created the image file that I'm going to be working through, and so I made a whole new list of new ones, and they were all bad. So now I'm using these good ones, and so that's why the last video was in white, and this is in black, right? So 7.2, graphing square root and cube root functions. So man, I totally didn't even know I did all this work. So I made my whole group of notes from this whole chapter, thinking I was like working ahead and stuff, making everything awesome. Turns out I was just redoing work that I'd already done, even better. Man, sucks. Anyway, whatever. So, old parent functions we've seen before. Wow, look at this. It's all like black and white. I remember this. I remember this. I haven't recorded a video for you guys in your actual lessons in so long. It's been like 5 months or 6 months. Jeez, no way. What colors did I even use? Green? Was green good? Green's okay. What about red? Oh, red's no. I thought students complained about red. Blue. Hey, that's a good one. Look at that. Anyway, so old parent functions we've seen before. Man, look at this. It's awesome. I'm pretty stoked. So this was the parent function, and this was the parent function, and that's definitely a star. Don't make fun of it. And this one looked like a V, and this one looked like a U, right? And we talked about transformations, where the number in front did something. If it was negative, it did something, plus or minus within the parentheses, or the function type did something. Plus or minus here did something. And it's the same thing. So this went up 6, this went down 8. This goes right 1, this goes left 4. This is a vertical stretch by 2, this is a vertical shrink by a half. Right? So, the point of me bringing up these prior function types that we've already talked about in previous chapters is because today we're doing graphing. We're doing the same exact thing, except instead of a squared function or an absolute value function, it's going to be a square root function. Simple as that. So, new parent functions, square roots and cube roots. Oh my goodness. Don't you just hate it? Never mind. If there was a camera on me, something would have changed, but whatever. So that's why I don't have a camera. Now, square root function, y equals the square root of x. That looks like this. And you can test this out by taking x, y, like an xy chart. If you plug in 0 for x, the square root of 0 is 0. So you plot 0. Plug in 4. The square root of 4 is 2. So over to 4, up to 2. Square root of 9 is 3. So you get this curve. Something to point out. This is an important piece of information. It never, it might look like it levels off, but it never does. It keeps going up, okay? That's something to consider. It'll keep going that way. It just goes that way slowly, okay? Next, the cube root. So here, the cube root of negative 9. You're saying what number times itself 3 times gives you negative 9? Well, that is cube root. Wait a second. Not 9. I want to go 8. Negative 8. So what number times itself 3 times gives you negative 8? Well, the answer is negative 2. So like this. Because negative 2 times negative 2 is positive 4 times negative 2 is negative 8. So then you're looking at negative 4. That'd be, excuse me. Man, why am I? 8. Really? I can't really do anything else that's a whole number. So I'll just go -1. And the cube root of -1 is -1, because -1 times itself 3 times, you can try it yourself, is -1. And then you can go +1 is +1, and then +8 is +2. And so you get this. And this looks like some sort of weird S. Whoops, that should not be a 3. This should be a 2. Looks like some sort of strange S. Oh man, oh no. I can do it. Perfect. Again, this does not level off, okay? It'll keep going up and it'll keep going down. All right? Okay. You need to have these memorized. Simple as that. You need to memorize the square root function, looks like this. Cube root function looks like this. Hey, something to point out. Notice how the square root function never crosses over here. And that is because you can't take square roots of negatives and end up with real numbers, right? You get complex numbers, I. Now, the general form. What is going on here? This is a 6. Why is this a 6? What am I, stupid? Don't answer that. This is supposed to be a K. Okay, so the point of this slide is to show you that everything is the same as we're used to. That number still stretches and shrinks the graph. The number inside here still moves it right, and if it's plus, it still moves it left. This number at the end still moves it up. If it's negative, still moves it down. None of this stuff has changed. Okay, so if you haven't got this down, maybe you're new to my class, write this down. This is the general form of these function types. It's the way you can see these functions in actual problems, and it will help you figure out what the graphs look like. So write all this down. But once you've got that, it should be pretty simple to go through. And the idea is that different things in the function do different things to the graph, as you might expect. First off, this is a square root function, because you see it's the square root of x. There's not the cube root, just the square root. So that's the parent function. And the parent function looks like this. That's the parent function. Our function has changed. There is this and this. Nothing else. All the rest of it is just the parent function. Right, so the square root of x, that's the parent function. That doesn't change. That's what creates the initial shape. The +3 underneath the radical, that does something special. The -1 outside the radical does something special. So let's look up here. Underneath the radical, hey, that's the letter h. And is it a -h or a +h? Well, it's a plus number. So +h moves left h. So this says moves, whoops, that's the wrong color. Moves left 3 units. Awesome. Wow, man, I miss this. All these cool black backdrop. And then -1 on the outside. Well, what letter is that? Well, that's K on the outside. Let's see what K does. A plus K goes up K. A minus K goes down K. So this goes down 1 unit. Okay, so let's do that. Let's go left 3 and down 1. So here's how you do it. You take every point here, this whole thing. Take this point, move it left 3, down 1. Left 3, down 1. Oh, look at that. This point here. Move left 3, 1, 2, 3, down 1. This point over here, left 3, 1, 2, 3, down 1. Oh, look at that. And you get this. And that's what you got. So this is your transformation. And this is the parent function. Okay, moving on. You guys at least try to get started on this problem. There's a couple of new things, but there's some old things too. And before you get started, One thing to consider is that this is not the square root of x, it is the cube root of x. And so your parent function's shape is going to change. It's going to look like this instead. Something like that. Now, try to pause the video and list these transformations. We haven't covered these explicitly yet, but I have talked about what the things in those positions do on the general form, okay? So, give that a shot. Pause the video, try to work it out. Okay, if you pause the video and resumed, I'm going to try to speed this up for you. There are these things that modify the graph. The negative does something special. All right, those are the things that modify the graph. First off, the -1 under the radical moves your graph right 1. The +2 outside the radical over here moves the graph up 2. The negative sign in front reflects... What is even going on? About x-axis. And then the 2 is a vertical stretch by a factor of 2. So, let's start doing all this stuff, shall we? The vertex moving right 1 and up 2. Here's the vertex, or it's not really the vertex, excuse me. It's really just like an anchor point, right? So this is like 0, 0 is like your anchor point. When I move around, I'm going to move that point around, all right? So I'm going to move that right 1 up 2, right 1 up 2. All right, so it's right there. Now, a vertical stretch by a factor of 2. That means that it's going to be like twice as pushed up, right? All the y values are going to double. So instead of being at 1, it would go to 2. The original function, instead of crossing here, would have doubled. Instead of crossing here, it would have doubled. So it's going to be like a wider curve. Instead, don't write this down, but instead of it looking something like this, instead of it looking something like this, where it's sort of flat, it'll be wider like this. Right, so it goes farther up and farther down. However, it's also going to reflect about the x-axis. So imagine that this was a piece of paper, and you took your piece of paper, and you folded it down to the bottom. This would fold down here. This would fold down to here. This, and then imagine you take the piece of paper and fold it up. This would fold up here. And it would look like something like this. That's what it would look like if you reflected it about the x-axis. So we're going to combine these ideas. It's going to stretch and flip. So it's going to look something like this. I'm not terribly interested in you being super accurate, all right? Just so that you understand the general idea, you know the parent function, you know where it moved, you can do the general shape. So the reason why it looks like that is the typical graph looks like this, right? Well, then it's going to stretch, so it's going to look a little wider. So this is what it would look like if it just looked a little wider. Maybe something like that. Same shape, starts down, moves up, but now it's going to flip. So here's that imaginary axis that you're reflecting over. So instead of going up, you're going to go down. Instead of going down, you're going to go up. Looks something like that. So this would be the actual answer. Okay? This curve here. I'll highlight it for you. This curve here is your actual answer. Something like that. Okay, now create a cube root function with the following transformations. A cube root function reflected over the x-axis, shifted up 9 and left 1. This is a cool problem. I like problems like this. Maybe that's why I gave it to you. So, it's a cube root function. That means I know there's going to be a cube root of x in it. Reflected over the x-axis. That means there's a negative sign in the front. I'll use different colors here. That means there's a negative in front. shifted up 9. That means there is a plus 9 on the outside of the radical. And then left 1 means there's a plus 1 in the radical. Boom. Done. Look at that. Easy peasy. A square root function shifted right 11 and down 5. You try that. Pause the video, try that. If you're still confused, rewind the video and watch how I did the previous one. Okay, so first off, it's a square root function. So it's going to have the square root of x in it. Then it's going to be shifted right 11. So there's going to be a minus 11 under the radical. And then there's going to be a down 5. And that is going to make us have a minus 5 on the outside. Boom, done. There's your homework. Make sure you're following the instructions. Don't do more than you have to do. That's that. So ask questions if you need help. Do your homework. Watch the homework solutions. If you actually make sure you're looking at the solutions to the assignments to make sure you're doing them correctly. If you aren't getting the right answers, make sure you are asking questions to figure out why you're not getting the right answers. All right. See ya.